Every single time you send a text or stream a video or make a call, you're plugging into this huge, invisible network all around us. But have you ever stopped to wonder how that network actually gets built? Well, today we're going to uncover the hidden story behind the tech that connects all of us. We're going to follow the incredible journey of a single piece of 5G hardware, from a box on the ground all the way to the sky. Let's get into it.
We're going to start right here. I know, this looks like a simple, kind of abstract line drawing, but it really gets to the heart of our story. It's about human hands, carefully, precisely, shaping the world we all connect to. This is our way into a world of incredible engineering that's happening just out of sight, way, way above our heads.
So what's the most important piece of this whole puzzle? Well, it all kicks off with a box, but what's inside, that's the hero of our story today. It's called the Active Antenna Unit, or AAU for short. And this thing is the powerful but often totally unseen device that makes our high-speed mobile world actually work.
To put it simply, an AAU is basically the brain and the mouth of a cell tower, all rolled into one. It's this incredibly specialized piece of tech that packs a powerful antenna right alongside a radio unit. Its entire job is to send and receive all those mobile signals that connect your phone to the network. And let me tell you, it is absolutely one of the most critical parts of any modern 5G system.
Okay, so how does this amazing piece of tech get from inside a box to the very top of a tower? Well, this flowchart here, this is our map for the whole journey. It lays out the entire process step by step, from all the initial prep work to the final moment they flip the switch. So let's follow the path and see exactly how it's done.
First things first, preparation. And we are not just talking about grabbing a toolbox here. No, you got to think of this more like a pre-flight checklist for a rocket launch. Seriously, the stakes are incredibly high, the equipment is super sensitive, and every single detail has to be absolutely perfect before the real work can even begin.
And who are the people pulling this off? Yeah, this is definitely not a one-person job. It takes a whole dedicated team, usually 4 to 5 specialists. And these aren't just your average contractors. We're talking about highly trained, qualified engineers who know this equipment inside and out. They know all the safety rules by heart, and they know exactly how to pull off a really complex operation without a single hitch.
Now let's talk about the tools for a second, because they tell a story of pure precision. On one side, you've got a multi-purpose wire stripper. That's for making perfect clean cuts. And on the other, a torque screwdriver. And that thing isn't just for making screws tight, it's for tightening them to an exact specification. We're talking about making sure every single connection is mechanically perfect. And that obsession with precision just keeps going. On the left, that's a heat gun. They use it to seal and waterproof all the connections so they can survive years of, blizzards and rainstorms. And on the right, that's an inclinometer. That little device is for setting the perfect angle on the antenna, aiming the signal with pinpoint accuracy to cover exactly where people need it most.
This just shows you how much every single millimeter matters. The official guide says you need a clearance of at least 300 millimeters on the top and sides and 500 millimeters below. So why be so specific? Well, it's all about preventing any kind of interference that could mess with the signal, and it also makes sure engineers have enough room to work if they have to come back for maintenance later. It's all about performance and making it last.
All right, with all the prep work finally done, we get to what is easily the most dramatic part of the whole operation, the big lift. This is the moment that heavy, sensitive AAU begins its journey, up, to its new home at the very top of our digital world.
And no two job sites are ever the same. As you can see right here, these teams have to adapt to completely different situations. Sometimes the AAU gets installed on a pretty simple single pole, on a rooftop. Other times, it's going onto a really complex rig attached to one of those massive lattice towers. Every single scenario has its own unique set of challenges.
Now let's just focus on one tiny, but absolutely critical number. 4 millimeters. For a lot of these installations, the steel pole's wall has to be a minimum of 4 millimeters thick. It really doesn't sound like much, does it? But that precise thickness is what guarantees the pole is strong enough to hold all that expensive gear and withstand decades of gale force winds and brutal weather.
And getting this thing up there takes way more than just muscle. It takes a carefully planned system. This is where heavy-duty ropes and a fixed pulley come into play. And the guide is very clear about this. They have to be rated to handle over 500 kilograms. That's more than 1,100 pounds. It's all about safety and having total control when you're hoisting this incredibly valuable piece of hardware.
Okay, the AAU is finally in position. Now the mission totally shifts gears. We go from heavy lifting to these really delicate final steps. This is the moment where all that precision engineering meets the real physical world, as they connect the hardware and get it ready to, well, bring it to life.
Making the right connections here is everything. There are three main types of cables they have to install. First is the PGND, or Protective Ground Cable. That's for safety. Second, you've got the power cables that give the unit all its juice. And third, the CPRI optical fibers. And these are the superhighways that carry all the data back and forth. Every single one is a vital link in the chain. Now this right here, this sums up the core philosophy of the entire operation. The manual says over and over again, use a torque wrench. See, it's not just about making a connection tight, it's about making a connection that is scientifically perfect, one that's engineered to survive years of vibration, wind, and weather, and never, ever come loose.
The very last hardware step is also one of the most important, adjusting the mechanical tilt. Remember that little inclinometer from the prep phase? This is its moment to shine. By making these tiny, little adjustments to the AAU's angle, engineers can fine-tune the signal, aiming the coverage area with just incredible precision to best serve everyone down on the ground below.
And with that, we finally reach the climax of our journey. After all that planning, all that lifting, and all that connecting, we've arrived at the final step, the moment this incredible piece of hardware becomes a living, breathing part of the network that connects every single one of us.
And there it is. The journey is complete. The active antenna unit is mounted securely, all the cables are plugged in, and the tilt is adjusted perfectly. It's just an amazing testament to all the preparation, the teamwork, and the sheer precision that we've just seen.
I mean, it's a pretty wild transformation when you really stop and think about it. It started out as just a piece of technology sitting in a simple box on the ground. And now, after this whole meticulous process, it's standing high up in the air, serving as a vital, active piece of the backbone of our entire wireless world.
So at the end of the day, what I hope you take away from all this is just a new appreciation for this hidden world that's all around us and above us. The next time you happen to glance up at a cell tower, you'll know the incredible story of engineering and human effort that it represents. So here's a question. The next time you use your phone, will you think about the amazing journey your signal takes?